Artificial intelligence, or AI, is about building systems that perform tasks requiring human-like intelligence. Learning, understanding language, recognizing patterns, and making decisions. Rather than a single technology, AI is a collection of methods aimed at simulating cognitive functions, from object recognition to strategic planning. Today, AI powers search engines, recommends products, and assists doctors, augmenting human abilities and automating complex tasks. The core of AI is learning from data, not just following explicit instructions. For example, to teach a computer what a cat is, you show it thousands of cat images. It learns the features on its own. This shift, from programming rules to learning from experience, makes AI powerful and adaptable. Most AI today is narrow AI, specialized for single tasks like medical imaging or language translation. The idea of a general human-like AI remains a distant goal. Current systems excel in specific domains only. Appreciating AI means seeing it as a set of data-driven tools transforming how we solve problems. It's less about conscious robots, more about practical, targeted solutions. Understanding this foundation is key to grasping AI's real-world impact. Data is the lifeblood of AI. Without it, systems can't learn or make predictions. For example, a spam filter learns from millions of labeled emails. A self-driving car learns from hours of driving footage. High-quality, unbiased data is essential. Flawed data leads to flawed AI. Algorithms are the instructions that process this data, finding patterns and making decisions. The choice of algorithm classification regression clustering shapes how the AI learns and what it can do. Data and algorithms work in a loop. Data trains the algorithm, which creates a model which is then tested and improved with more data. For instance, music recommendation systems analyze your listening habits and those of millions of others to suggest new songs. The algorithm is the recipe, the data, the ingredients. Together, they create personalized, intelligent experiences. This cycle, data feeding algorithms, algorithms refining models, is at the heart of AI development. The better the data and algorithm, the smarter the AI. That's how AI systems continually improve and adapt. AI learns through different methods, each suited to specific problems. Supervised learning uses labeled data like images tagged with animal names to teach the system to make accurate predictions. Unsupervised learning finds patterns in unlabeled data, grouping similar items or discovering hidden structures, such as clustering news articles by topic. Reinforcement learning teaches AI through trial and error, rewarding good actions like an AI learning to play a video game by maximizing its score. These methods shape the AI model, the trained system that makes predictions or decisions. For example, a model trained on labeled X-rays can spot pneumonia in new images. The learning method is the teaching process. The model is the result. The choice, supervised, unsupervised, or reinforcement, depends on the data and the problem. Each method unlocks different capabilities. Together, they drive AI's ability to learn and adapt. Powerful hardware is essential for running AI, especially deep learning, which needs fast, specialized processors. GPUs and newer chips like TPUs are designed for the massive parallel calculations AI requires. In real-world applications like self-driving cars, this hardware processes sensor data in real time for instant decisions. Hardware isn't just a platform, it's a key enabler of AI's speed and capability. User interaction connects AI to people, whether through a chatbot, a voice assistant, or a medical dashboard. Good design makes AI's output understandable and useful. For example, a smart speaker captures your voice, sends it to powerful servers, and returns a spoken response. Hardware runs the models, user interfaces deliver the results. This partnership brings AI from code to daily life. The combination of robust hardware and thoughtful interaction is what makes AI practical and accessible. AI is built from interconnected parts: data, algorithms, learning methods, models, hardware, and user interaction. Understanding these elements demystifies AI and reveals both its power and its limits. Data quality shapes outcomes. Hardware determines speed. User interfaces affect usability. As AI becomes part of finance, healthcare, and more, everyone, not just experts, needs to understand how it works. This knowledge helps us ask critical questions, spot risks, and ensure AI is used responsibly. With a clear grasp of AI's architecture, we can shape its future for the better. We move from passive users to informed participants. By understanding the blueprint, we help build a future where AI serves us all.